Hello, everyone. Today we're going to present our Archive Scholar Agent application. So Archive Scholar Agent is an intelligent research assistant. Recent developments in large language models have significantly expanded the possibilities for intelligent information processing and human-computer interaction. However, research remains difficult for many individuals to navigate. Scientific articles are often dense, highly technical, and time-consuming to interpret. Uh, Most of the time, students, educators, and professionals identify relevant literature, but they have challenges when trying to understand complex theoretical concepts, uh, summarizing lengthy papers, or to synthesize information across multiple sources. So this highlights the need for intelligent systems that can support users in engaging in a more um, efficient and effective way when doing their research. The Archive Scholar Agent is an AI-driven research assistant designed to improve the accessibility of scientific literature. The agent integrates traditional information retrieval methods with modern large language model capabilities to support these academic tasks. Its primary features include semantic search, automated summarization, simplified explanation of technical content, and multi-paper comparison retrieval augmented conversational question answering. The system also incorporates vector-based indexing that enables users to interact conversationally with the full content of a paper rather than relying only on abstract or metadata. So now let's take a quick look at the app. So this is the interface. And here in the search box, we can enter the topic that we are searching for. In this case, for the example, we're going to use LLMs. We click search. We can see the papers that have been retrieved, right? And in this case, we're going to select the first one just for testing purposes. So we can see the abstract as presented in the original document. We can also take a look at the document itself in case we can do like a quick scan. We can request an AI summary. We click here, generate summary. And if needed, the user can request a second summary. So let's take a look at simple explanations. And this is a very useful feature because what the app does is that it breaks down the content into concise concepts. So let's take a look at it. Mhm. So here we can see like how it is providing brief paragraphs and sentences explaining to the user what the paper is about, what are those main risks that the paper encompasses, right? Um, And it also provides some examples. Additionally, we have the chat with paper feature. See, okay. So in this area, we can use natural language, which is awesome. So let's take a look at this. What is here we can see that the document has been indexed, um, and it's using some of the chunks to provide the information or the response to the user, so we can see which chunks are being used. And we can also see the citations in different formats. And now I'm going to hand it over to Giju.
Thanks, Wendy. So I'll mainly begin with the architecture and the data flow, and then why we use certain components in this project. So I'll start with that. So as we can see, the project it all starts with the presentation layer. This is what the users see on the screen: the search, the AI summary, and then the rack chat experience. Everything is through this presentation front end. So basically, we have kept front end simple. It's HTML, CSS, and JavaScript. We have a couple of .html files and then the JS. Next comes the API layer. So for API, we are using Fast API server. This is extremely fast REST API framework. It is lightweight and asynchronous, secure, scalable. We have all the latest and greatest here. So we have couple of endpoints like the search endpoint, the chat endpoint, the summarize endpoint. All these are linked to the front end. So that way, and then the REST API connects to the orchestration desk. Uh, and the entire backend system is through the REST API. So front end is right now only connecting to the fast API endpoint, and then fast API internally connects to everything, takes care of everything. So that's about the second API layer. Then comes the orchestration layer. This layer is very important. We are using LangChain and LangGraph for agent orchestration and tool usage. So from LangChain, we are using a couple of utilities like document loader, text chunking, vector storage, embedding, and then the retriever prompt template chaining. From the LangGraph, we are using workflows and nodes. We are setting everything into a graph-based workflow. We have nodes. I'll talk about this section in the data flow part. Next comes the service layer. So we are connecting to the archives database or the API. We have access to those research papers and additional details on those research paper. Then we have PDF file processor. We have PDF file reader, chunkers, loader, and everything is there, and everything related to the PDF files are here. We have LLM service and vector store services also. Then comes the external API. So like I talked about earlier, we have archive API as our external API. We are connecting to the external API exposed through a Python package for archive. Then we have a gateway router. We are using Open Routers Gate API gateway, so we can switch between LLMs here. Then we are using text embedding 3 large from Open API. This is one of the best embedding model provided by Open API. Then we are using Chroma DB. Everything is simple, local, and configurable. Then for the paper storage, for the saved papers, we are storing everything in our local storage browser's local storage. Next, I'll walk you through the data flow. So if we have to talk about research paper search, so ideally, what would be the data flow for a paper search? So it all starts with front end. Users have option to search for a certain topic or a certain keyword, or a research topic or something. Let's say if I have to search for what is the latest and greatest in AI agent, user would simply pass that question as a natural language English question into the UI, and then it comes to the API layer. It uses this API search endpoint. Next, it would use the LangGraphs workflow. So we have multiple workflows for for the AI agent to work. For the current, the one of the best reasons why we have what LangGraph provides is all these workflows have its own path. So they don't their paths don't conflict, and each path has multiple nodes. So each node does its own task. So that way, if I have to add a new path or workflow into it, let's say I want a mind map to be generated, or I want better documentation, or better try to find some pictures so that I can understand a certain topic. So I simply come here and add a new workflow and couple of nodes to make the execution of that workflow work better. So that way, it's all modularized, categorized, so we do not have to worry about anything when we future work on the enhancements. So that's one good thing about this. So as part of data flow, we have reached the search. It follows its own path. It uses the search node, does the execution. Uh, it connects to the archive client. It uses the API gateway. If there is a chat experience needed, connects to the vector embedding stored, the chunking metadata, everything connect to the vector DB, gets the response back to the UI. So that's about the data flow. So we have kept it very simple, modular, and then scalable. And everything is cheap here. Everything is below $5 for this POC, for this demo application. And then if you think about what benefit is user getting from this, so if we think about how it is done manually, it would take a lot of time and a lot of effort to get something done manually. For example, if for me as a user, if I have to build a RAG solution, first I would have to understand different type of RAG approaches. So I would have to read or go through multiple technical research paper, understand how different how people have implemented it, what is the current standard, and how many different type of RAG solutions are already there, how it is implemented, look into the diagrams, the code, and everything. But think about this automated AI assistant. We simply have to pass a topic in the natural language. It tries to search for different papers. It gets the code. It tries to give you a precise information, or step by step help you build a mind map, so that the learner or the user can understand, uh, and ask questions on top of that, implement it in modules, and that way they can implement it incrementally, and every all this chat and all the interactions are saved for future reference. So we have those additional features which we have planned for the future enhancement. So one future enhancement which we thought about is to improve the RAG chat experience, reduce hallucination as much as possible, improve the search. So if we are not having enough context about what has to be built, let's say I am planning to build an AI agent, but I do not have enough understanding on what is needed, what tech stack is needed. So even that simple layman term questions can be asked. It searches for multiple research paper. It gives an ideation back saying that these papers have this listed, and this is kind of diagram of what is already implemented. I can help you further by implementing an architecture diagram for what you're looking for. This is how the code should be structured. This is how currently those applications which are there in the paper is currently implemented through these codes, and these are the references. We, in the future for the enhancement, we are looking for something like that. So yeah, so this I personally feel this for a researcher or for an employee who is mostly into advanced project, this would be very useful, and it saves a lot of time and effort. So yeah, so that's about this presentation. Thank you.